As we begin our reading sessions, I want to give you a few tips and tricks on the use of your ECG calipers. First of all, be careful with them. Before you put them in your pocket, make sure you have the little cover on. Believe me, it's happened to me several times, and I was very painfully reminded of what I'd done. The second thing is the little prongs on your calipers are all adjustable. If you look on the sides, you can see a little screw that you can use to adjust the length of the prongs on each side. They're mainly there to make sure that the prongs are of equal length so that you're not tilting to one side or the other as you're trying to measure an interval on the ECG tracing. Okay, now let's talk a little bit how to use these the right way and the wrong way, and a few intermediate ways. Let's say we want to measure an RR interval. Okay, we have an R, we're going to use this bottom line down here. We have two sinus-conducted P waves, so we know that this is the baseline RR interval for this patient on this ECG. A lot of people will measure the RR interval by placing one prong on the peak of the R wave and the other prong on the peak of the next R wave. Well, as long as there is a very steady sinus rhythm with no other problems, that will work. But I think you will find out very quickly that regular sinus rhythm may be a lot of things, but regular is not one of them. So the correct way to measure an interval, whether it's an RR interval or a PP interval, is to measure from the beginning of the deflection. Okay? In this case, it's the same. We could have done it with the peak, but I'm going to show you why we don't do it that way here in just a moment. Now, we can also measure the RR intervals. Let's skip up here, and we're going to measure we're going to measure PP intervals from this P wave to this P wave. Again, for these two beats, it's the same. Now, let's come down here, and we're going to measure an RR interval from the peak of this QRS complex to the peak of the R wave, or of this PVC, premature ventricular complex. Okay, this is our RR interval. From the peak of this QRS, the normal QRS, to the peak of the PVC. But now let's try measuring it at the base, at the beginning of each deflection. And we can see very quickly that there is a difference. Had we measured at the base, at the beginning of each deflection, we'd have seen that there would be a difference up here. So again, this is why we measure from the base, or the beginning of each deflection, to the beginning of the next deflection. Now, sometimes, especially with P waves, it's very difficult to tell exactly where the deflection begins. In those cases, measuring from peak to peak is unfortunately about all you can do. So yeah, we do that from time to time. It's best to do it if the P wave comes to a peak. Now, for instance, if we look at these biphasic P waves up here, which you probably have surmised this has got to be lead V1, we were able to easily measure from the beginning of the P wave to the beginning of the next P wave. But had we not been able to, these P waves form enough of a peak where we could have measured peak to peak if we had to. But when we look down at these P waves here, they're very broad. I mean, trying to decide where exactly the middle is could be a little problematic. Fortunately, again, we can measure from beginning to beginning. But the correct way to measure an interval is from the beginning of one deflection to the beginning of the next deflection. Okay, Now let's look at something else on this tracing. If we look right here, there is a big pause from this PVC to this sinus-conducted QRS complex. We don't see any pause like that anywhere else on the tracing, just right here. Could this be a compensatory pause? If it is, it would have to be equal to exactly 2 PP intervals. Now, assuming that the PP intervals are occurring on a very regular basis, it could be equal also to 2 RR intervals. But we want to know if there was a compensatory pause here. Well, the compensatory pause is equal to 2 sinus PP intervals. Not RR intervals, PP intervals. If it's a compensatory pause, it will be equal to 2 PP intervals. Well, we only have 2 consecutive sinus P waves here. That's one interval, but we need to measure 2. So we can measure 2, and what a lot of people do is they'll come up here to the grid on the ECG paper, and you can count 1, 2, 3, 4, 5. There are 5 boxes here, and so 2 PP intervals would be 10 boxes, so we'd have to count out 10 boxes. There's actually a much faster way to do this. If we measure the interval here, that's 1 PP interval. Now watch what I'm going to do. I'm going to shift the calipers over, leaving them in exactly the same position. I'm going to kind of stabilize or fix this prong right here, and I'm just going to extend this back to that second sinus P wave. I now have 2 PP intervals. Well, we're not going to be able to measure PP intervals here because we can't see any P wave. But again, we're going to have to make the assumption that the RR intervals, 1 RR interval is equal to 1 PP interval. And if we measure that, we see that it is indeed in this case. And this is a fully compensatory pause. Now, let me measure that again one more time. And I'm going to start with the beginning of the P wave, and I'm going to end with the beginning of the next P wave. So now I have my calipers set at 1 PP interval, which coincidentally is 1 RR interval. Now, to make this equivalent to 2 PP intervals, without changing my calipers, I'm just going to move them over and set this prong down here. I'm going to stabilize this prong so it doesn't move, and I'm going to extend my calipers back to the beginning of that second sinus P wave, and I now have 2 PP intervals, or 2 RR intervals. Okay, now if we wanted to measure where P waves might show up, one thing we can do is go back and we can measure the PP interval, and we can just kind of move our calipers like this. But a lot of people will walk the calipers. Let me fix this here. Okay, and I'm going to move this down here where you can see it better. Let's say we were measuring RR intervals, and then, whoops, by walking the calipers, we just walk it like that. The problem you get into when you do walking like that is sometimes you'll move the calipers and the width here will change without you realizing it, and suddenly you're getting results that's incorrect and can really throw you off. I don't recommend walking the calipers. It really is kind of I think more trouble than it's worth. So I wouldn't recommend doing that. Now, another thing we can do with the calipers. Here we have a very rapid, wide, complex tachycardia. Is this ventricular tachycardia? Or could this be an atrial fibrillation that's being conducted down through an accessory pathway? The accessory pathways can conduct much more rapidly than the AV node can. And so this is something that we see from time to time in people who do have Kent bundles or accessory pathways. What you learn is that the more rapid a rhythm, the more regular it will appear, even if it's not. And as you get very, very fast, even the irregularities become very minuscule, but they're still there. If we wanted to measure this, some people would just measure each peak, each interval. And here we have to measure peak to peak because it's a little problematic deciding exactly where each QRS complex begins. Some of them are not exact. They're not off by much. But another thing you can do that's a lot faster is you simply plant your prong on one of the peaks and just move it down a whole bunch of them like this. And then we can see we're a little off here. We're a little off there. We're off there a little bit. By extending the calipers 6, 7, 8, 9 beats, you will amplify the differences so they're a little bit easier to see much more quickly. Here, again, this is not a huge difference, but at this rate, it's still a significant difference. This indeed is atrial fibrillation being transmitted to the ventricles via an accessory pathway. It was not only proved at the EP lab, however, the rest of the tracing, which I have cut off, became much more evident of atrial fibrillation. So there's no question. This is atrial fibrillation. And instead of just measuring each interval separately, extend your calipers out a number of intervals, and then you'll see that it's close, but like the people in the carnivals would say, close but no cigar. So this is indeed atrial fibrillation, and we learned that in just by measuring 2 or 3 intervals. We didn't have to measure each interval separately. Okay, well, I hope you have learned something today and will be able to take advantage of these little tips and tricks. We're now ready to begin our interpretation of the 12-lead ECGs. Good luck to you.